All right, objective 1-4, angle measures. An angle is formed by two intersecting lines. The sides of the angle are segments. The endpoint is the vertex of the angle. You can think about the vertex as being the corner. When you see this little, it's a less than symbol, it's kind of what it looks like. That means angle symbol. So anytime you see that symbol with some letters after it, we're talking about an angle. We can name angles in several different ways. In our first little example right here, we can just use that number 2 and we could say angle 2. We could also just use this one letter since that's the only corner there, and we could call that angle B. Or if we wanted to make sure we were completely understanding what angle that we're talking about, we can use these points that surround the angle. We could say angle A, B, D. All right, so that means we're going starting at A, we go down to B, and then we finish it off by D, so we know exactly which one we're going. And we can also switch that around, and we could say D, B, A. Now, whenever we use the vertex to name the angle, then there can only be one angle with that vertex. For example, on this bottom picture, we couldn't just simply say angle R because we could be talking about, let me change the color here. We could be talking about this angle 1, or we might be talking about that angle 2. So in this case, we'd have to be very specific, and we would either have to say angle 1, angle SRT, or we would say angle TRS. And on the other side, the pink side, we could say angle 2, or we could say angle TRU, or we might want to refer to it as angle URT. We can talk about the interior of an angle, and we can talk about the exterior of the angle. The set of all points between the sides of the angle is the interior of an angle. So that's this in this yellow highlighted area. If you think about an alligator and an alligator closing its mouth, well, anywhere its mouth is going to close will be on the interior of that angle. Everything else on the outside is the exterior of the angle. So let's look at our problem down here. We can have things being on the angle, on the interior of the angle, or on the exterior of the angle. So if we're on the angle, we would be on that little blue line. So we've got points A, D, and E. Okay? A, D, and E lie on the angle. The interior of the angle, well, that would be that little highlighted area. See how I kind of connect those two endpoints? They're not really endpoints, but they kind of are. So what's on the inside in that yellow? Point C and point B. We wouldn't include A, D, and E because they're actually on it and making it up. So what's not highlighted, what's on the outside? F and G. Okay, so we got some example problems here. Name all the angles that have W as a vertex. Here's W. So I got angle 1, angle 3, and angle 2. That would be okay. And for some clarification, angle 1 is the same thing as XWZ, or if you want to switch that and say angle ZWX, you could. Angle 3 is angle ZWY, or if you wanted to call it YWZ. And then angle 2 is angle VWY, or if you wanted to call it YWV. All right, so there's kind of how different ways you can name each one of those angles. The sides of angle 1. All right, here's angle 1. So XW and WZ. They kind of box in that angle. And then write another name for angle WYZ. Pretty sure we've already done that. Oh, no, we didn't do WYZ. All right, so here's W. And I'm going to go, where's Y? Well, Y is down here. And now I've got to connect over to Z. So I could say angle 4. Or I could be fancy and say angle ZYW. All right, either of those two angles, those two names would work. All right, so measuring angles. Now, this little protractor device, we probably won't have to physically use one, but you got an IXL assignment where you have to do some measuring. And this is how this works. You put the origin on the vertex. This right here, highlighted, that little dot, that is where the origin, that's the origin that you put like on the corner, the vertex of your angle. Okay? So if you're reading the angle, if the angle is kind of open to your right, you would be reading it counterclockwise, and you would read the bottom number, and that's the blue side. If the angle is kind of open to your left, you're reading it clockwise, and then you've got to read the top number. This explanation of it and looking at both of those numbers can get really confusing. So, for instance, let's do a quick example right here. Let's go with green. E. All right. That green angle going that direction is what? 100. Ooh, you're not going to be able to see that. That would be 120 degrees. Okay? Do you see that? All right. So let's undo some stuff. Come on. I'm going to redo that. Now let's look at it from this way. Oh, need my marker. I want it to be bigger. I'm at E again, but I want to read that angle. And in this case, I'm reading it this direction. And then I'm going to look, and it would be 60 degrees, okay? So depending on which way the angle is facing determines if you're going to read the top or bottom number. All right, types of angles. There's 4 types of angles. There's an acute angle, measures greater than 0 but less than 90, so it's small. It's a small angle. We got a right angle that's exactly 90 degrees. We have an obtuse angle. It's greater than 90 but less than 180. So we think about it as being a big angle. And then we have a straight angle. Straight angle, straight line, 180 degrees. All right. So let's look at my little diagram right here. Classify each angle as right, obtuse, straight, or acute. So, PMQ. PMQ. What does that look like to you? Yeah, I think that's acute. All right. Let's go with PMR. What does PMR look like? Yeah, I think it's a right. All right. QMS. QMS. Well, I think it's right. I'm not 100% sure, though, if it's right, but I would guess that it's a right angle. PMT. What's that one? Yeah, that's just a straight line. You know what? My marker's too big here. Acute. Acute. Right. Right. I'm color coding these. And we said QMS. We thought QMS was right too, but we're not 100% sure. PMT. Oh yeah, we said PMT was definitely straight. All right. PMS. PMS looks obtuse. So let's call that one obtuse. And then the last one, RMQ. RMQ. That looks acute, so that one should be green. All right. All right, one more slide. Congruent angles are angles that have the same measure. In the diagram, the M, whenever you see this little M right here, that means the measure of angle ABC is equal to the measure of angle DEF. So you can say that those two angles are congruent. This math sentence, this is read as angle ABC is congruent to angle DEF. Arc marks. Arc marks. Arc marks. Wow, what do those arc marks look like? Those arc marks kind of look like those line segment marks that we made when those segments were congruent. So if we make little marks on the arcs, then those are congruent angles. What can you do if two things are congruent? What did we do with the segments when they were congruent to each other? Angle ABC is congruent to DBF. The measure of angle ABC is 6x plus 2, and the measure of DBF is 8x minus 14. If they're congruent to each other, set them equal to each other, and do what? And solve for x. Isn't that wonderful? So 6x plus 2 equals 8x minus 14. Where's my handy dandy calculator? Yay! 6x plus 2 equals 8x minus 14. X is 8. Is that my answer? No, I actually need to find the measure of each one of those angles. So this is where we're going to substitute x back into the equations. The expressions, rather. So 6x plus 2. That's what one of the expressions were. Now right there where that x is, I want to substitute in that 8 and I'm going to get angle ABC equals 50 degrees. If those two angles are congruent, what should DBF be when I back substitute? 8 times 8 minus 14, yep, it's 50. So we can see that angle ABC and angle DBF are both 50 degrees. That's it, ladies and gentlemen. That is angle measures.